Now the inorganic acids are very strong acids, and they can really burn living tissue as well as the clothes and even wood. Even if you pour them on cemented floor, you will find that it has started getting corroded. So we have to be very careful when we are using the strong acids, especially in the concentrated form. So what is the solution? The solution is that we can dilute it. Now what does that mean? That means we add water. So if this is the sulfuric acid, concentrated sulfuric acid, then do we add water? I told you last time also what will happen. There will be so much of splashing that the acid can fall on your face. You must always keep the test tube away from your face, and also never add water to sulfuric acid. In fact, what is done is that we take water in a tube and then add sulfuric acid. Even then there is a lot of heat released, so it is an exothermic reaction. Which other reaction is exothermic? When we added water to calcium oxide. So in the case of acids, if we want to dilute them, we must always pour acid into water and very slowly, so that it is safe. So what happens? Why then it becomes diluted? Because the number of ions or the amount of acid per unit volume is reduced because there is more water. So acid per unit volume is reduced. So that is why whatever is available in the market is always diluted acid. In the labs also we generally try to keep the diluted acid, and concentrated acid is kept very, very safely because they can be very dangerous. So this is how we can dilute an acid. If we talk of strength of acids and bases, then we can easily conclude that all acids are not equally strong. So how to measure the acidity of a particular acid? Similarly, the basicity of a particular base. For this purpose, a scale has been determined, and this is called pH scale. In the pH, with the way we write, P is small and H is a little bigger. So this is the pH scale, where P stands for a German word potens, which means power. So we have a pH scale by which we can measure the acidity or the basicity of a substance. If we take it like this, what we find is that the scale is from 0 to 14. It keeps on becoming narrow. The neutral is at 7. So 0 to 7 is acid and 7 to 14 is base. Now just to understand a little more clearly, at 1.2 is gastric juice, and you know that gastric juice has HCl in it. The lime juice, which has citric acid in it, is 2.2. At 7.4 we have pure water. So pure water is not absolutely neutral. At 10 we have milk of magnesia. And at 14 we have sodium hydroxide. So as the pH reduces, it becomes acidic. As it increases, it becomes basic. In agriculture, the pH value of soil is very important. Due to the excessive usage of fertilizers, the pH value changes, and as a result, the soil can become acidic or basic. If the fertilizer used is, say, sodium nitrate or potassium nitrate, and the soil needed potassium, it was deficient in potassium, then the nitrate ion is left in the soil, and so the soil turns acidic. And if nitrogen was needed by the plant, then potassium ion will increase in the soil and it will become basic. So what we can do is that we can check the pH value of the soil. You can do it at home also, and after you have found out whether it is acidic or basic, then accordingly the fertilizer can be used so that it can become neutral and the crop yield can be good. Or we can also find that what kind of pH value is required for a particular crop. So in the soil also, pH value plays a very important role, because after all, crops are living and they need a specific pH value. Now what is this common salt that we add to our food? It is sodium chloride. It is available in the sea water. So when we want to extract this salt, we collect sea water in narrow, pits, and as water evaporates, salt is left. And of course then it is refined. The sea salt also has iodine. So it is iodized salt, which is so very important for the growth, physical, both mental and physical growth of children and adults alike. So iodine, is a part of thyroxine, and so it is a very important part for the growth of the body. Now sodium chloride can be produced by the action of hydrochloric acid and NaOH. So we get salt, common salt plus water. Now what happens if we pass electric current through NaCl? What will happen is, it will produce NaOH, hydrogen and chlorine. NaCl plus water gives us H2 plus Cl2. Now hydrogen is a positive ion, so it will get collected at the anode, while the chlorine will get collected at the cathode. So now we will understand what are the uses of hydrogen. Hydrogen is needed for manufacturing ammonia, for making fertilizers. Hydrogen is also used for hydrogenation of vegetable oil. You see, the vegetable oils have unsaturated fats. To saturate them, we use hydrogen. So we can say it is used in margarine. These are the uses of hydrogen.